So hello Near, what is this technology? Here's our story, right? It's cheaper, it's faster, it's easier to use. Let me turn on the light here. Cheaper, faster, and easier to use for development and in production, right? So I'm not going to read these slides to you, you can read them, but there's many JavaScript developers out there. We're trying to make it easier for them to work with this technology. Rust toolchain, Rust to WASM, because it's a WASM virtual machine that we're using, is the most mature in the industry. So it's fantastic to have Rust as a contract language as well. And the unique account system is a big deal. A lot of people like that. If you're coming from Ethereum, that's going to be your biggest challenge, actually. So if you're familiar with Ethereum development, we're going to need to clear up the difference between the Near account model and the Ethereum account model. Okay, and there are a few optimizations built in here. I assume that you can read this. So at a high level, and by the way, previous recordings of this go into much more detail. So I'm trying to make each one of these presentations a little bit different so they can, in aggregate kind of make something that you can binge watch as an intro to the course. And so here we're doing a very light treatment of this. If you want to see a little bit more detail, please watch one of the previous recordings. You can kind of fast forward or look at the table of contents to find what it is that you want to watch. They're all on YouTube. And you just search for NCD kickoff, or in the landing page, you'll see the previous recordings from the 3 previous cohorts. So here at a high level, you got the blockchain on the right-hand side, RPC interface remote procedure called JSON over HTTP to communicate with the blockchain. That's our API. And then we wrap that with a JavaScript, library that makes it easy in JavaScript to communicate with the API. But we could just as easily do that with Ruby or Go or Kotlin or Swift, right, to wrap this API. So there's no limit to sort of what you can do with that API in the end. It's just an API. You're sending text over the wire, JSON over HTTP. And then your decentralized application, your dApp, will consume that API if it's running in a JavaScript context. If it's a mobile application on iOS, maybe you want to create your own custom Swift wrapper for the RPC interface. If it's on Android, maybe your own custom Kotlin wrapper for the RPC interface. And there are bounties in the community for that. So you can earn money to do that, by the way. And then the bottom below your dApp are all of our tools, the examples, Near Explorer, Near Wallet, Near CLI. So the examples near.dev, there's many examples there you can use. That's a URL, near.dev. Near Explorer, you can type explorer.near.org. That's our blockchain explorer. It shows you, what's happening, the transactions and the validators and what's going on. That's at explorer.near.org. Near Wallet, wallet.near.org is where you would create an account, manage your own wallet, send and receive money, things like that. And then Near CLI is the command line interface. npm install -g for global, near-CLI if you're familiar with Node, but I'll show you instructions a little bit later for that. So we use exactly the same. Yeah, please go ahead.
Yeah, so I just want to know that a decentralized app, what is the exact difference between the normal application and decentralized app? Is it like the app which interacts with the blockchain or which communicate with the smart contract using the Web3.js? Is it called dApp, or how it's exactly different with the actual application?
Yeah, let me try and answer that. So, and others in the call may have a better answer, so feel free to chime in, by the way. But the word decentralized here is about the resilience of the system. So when you build an application on a Facebook plugin or whatever, a Facebook app for the market, Facebook can shut you down. When you open a YouTube channel, YouTube can shut you down. When you have an Instagram account, Instagram can shut you down. That's centralized. There is some authority, be it government or company, a corporate entity or whatever, multinational, doesn't matter, that can shut you down. It's up to them to decide, do you have the right to exist? That's the key. And this is at an application layer, but also at an infrastructure layer. Like some people use hosting providers that take down the entire website because they get some kind of, request to take down the material, right? So it's at every layer of the application architecture, right? From the application layer, plugins, things like that, down to the sort of infrastructure and kind of, virtualized hardware, I guess, would be the closest thing today. So that's centralized. Some authority can shut you down. Decentralized is nobody can shut you down. No government, no state entity, not the richest person in the world. They can't say, I don't like what you're doing, turn it off. They don't have the power or the means or the technology or the resources to do that. That's what decentralized means effectively. That's the definition, my understanding of it. And so when you're connecting with a blockchain that is well-supported, economically viable, decentralized, meaning many validators or many people doing a proof of work, many miners, that gives you the security. As long as one miner or one validator is online, your application will survive. Does that answer your question?
Yeah. So suppose if I have an app, okay, I have built a normal app, maybe using any of the front end or maybe any of the web development tools, and so how or where I will deploy to make it or called as decentralized?
Yeah, so we'll get into that, but the decentralized part is the blockchain part.
Okay.
So you send your WASM, your WebAssembly compiled contracts written in AssemblyScript or Rust. You compile them to WebAssembly, and then you send them using a transaction. You send them to the network. It's a deploy contract action. Actually, you send it to the network, and there it lives. It sort of turns on and turns off like a serverless function whenever you call it. You have 200 milliseconds to do your work.
Okay, got it.
Yeah?
Thank you very much.
Yeah, of course. Yeah, feel free to interrupt. Yeah, sorry, Sasha. Go ahead.
Yeah. So I will put it like simple way, like literally blockchain allows your application operate, manipulate, read, and write data that is stored on blockchain. It's like kind of nobody can edit like retrospectively. And that's actually the point. When you use like Amazon Cloud or whatever, like they can just cut access to that database or their computation services, whatever. Like blockchain, no, you just use it.
Thank you.
Okay, so sorry, just Gabriel is asking, can you review the bottom half of the last slide? Very briefly, Gabriel, but please watch the other recordings if you need a little bit more. So in a production side, the NEAR is many hundreds or thousands of times cheaper than Ethereum in terms of gas costs. The contract earns 30% of transaction fees, the other 70% are burned. And so the network might become inflationary with enough usage, for example. That's written about in our economics white paper. The sharding protocol reserves the right to redistribute accounts across shards. That's our parallelization story. And maybe we'll see a slide about that here. If not, you can look at other recordings of this presentation where we talk about shards and parallelization and how several organizations in this third generation of blockchain companies are solving this problem, including Polkadot and Solana and Avalanche. And 1 second block time means things are snappy. Ethereum takes 15 seconds. Bitcoin takes 15 minutes to finalize a block. We do it in about a second. There are some organizations that do it faster. And so this is important because it means that your interaction with the blockchain is fast, basically. When you do a thing, you know it's done. Okay?
Gotcha. Thanks a lot.
Of course, yeah. Keep asking. This is exactly the right thing. Let me be the judge of whether or not we have time to spend and how much time it is. So you be selfish, I'll be sustainably generous, and hopefully everybody else around you as well. Okay, that's kind of the protocol for how we're engaging. So at a lower level, just moving through these steps, again, this is covered in more detail in previous recordings, but very briefly, on the left-hand side, you've got your app. You're using Near API.js to interact with the blockchain. You've written your contracts using one of the 2 software development kits for AssemblyScript or Rust. You deploy those to the storage under some account that you've created. And then you use Near API.js to send a transaction. It gets applied. The virtual machine will load your code. That's in step 4. Spin up, give you 200 teragas, about 200 milliseconds worth of clock time to do your work, reading and writing to storage, and then send the response back, which you'll then receive and render into your interface or whatever it is. So it's like any other interaction that you would expect with any other API. It's not some unusual structure. The only difference is you're customizing the backend by writing these smart contracts, which are operating some interface for storage and compute on the blockchain. That's what you're getting with these smart contracts.